So there's obviously, this is obviously a displacement vector, okay? So for example, if we put in a t value of 2, what happens? T cubed would be 2 cubed, which is 8. And then 19 minus t squared would be 19 minus 2 squared, which is 15. So that means at that point in time, you're 8i and 15j away from your point 0. So if your point 0 is here, you're 8 across and 15 up. So you're up here somewhere at the point 8, 15. Is that okay? Isn't that minus? Oh no, sorry, we're not squaring the minus because the minus isn't in the bracket. So you're thinking it's that, but it's actually this. Is that okay? Don't do that in a month. All right. Next thing. How far from O is the particle at t equals 2? Well, we just sort of discussed that a minute ago. It's 8 across and 15 up. So use Pythagoras' theorem. What you get? 8 squared plus 15 squared. I think it's 7 then. But know this off by heart. Yeah, I do know off by heart. Oh, it's sad. You will. You're doing engineering? Yeah. Okay. The velocity factor. Well, this is very similar to what we did before, isn't it? If your initial equation is distance or displacement, your first derivative should be velocity. So what do you think? Differentiate, and what do we get? It's question 2, isn't it? Yeah. So 3t squared I, differentiate t squared, and then differentiate the other one. Minus 2t j, and that tells you your velocity at any given point. Okay?
Yeah, you're doing it like
yeah.
Differentiating the displacement velocity.
No. There's a difference between speed and velocity. Okay? The first thing is we're going to find the velocity at t equals 2. So sub in 2, and we get 3 times 2 squared. Would you all be happy with 12i? And then 2 times 2, 4j. Now that's the velocity, it's not the speed. You're going 12 across, 4 down, right? So we're going to have to do Pythagoras' theorem to find the speed. Okay, so square root of 160. Because it's 144 plus 16, which is square root of 60. Which is? 4 root 10. Which is 12.65? 12.65 meter per second. Is that okay? Now that we've done that, it also wants us to find the acceleration vector. Take a wild guess what you think the acceleration vector is. Huh? Differentiate the velocity to get acceleration. If you had the acceleration and you're looking for the velocity, you would integrate it. If you had the velocity and you're looking for the displacement, integrate it. Yeah. So what do we get then? 6ti, yeah? And what's the other one? Minus 2j. Yeah. Then what does it want from us next? Find the acceleration vector when t equals 2. So sub in 2. You get 12i minus 2j. Vector. So then if you're asked for the overall magnitude of the acceleration, you do Pythagoras' theorem again. Yeah. But it just asks you for the acceleration vector, so you leave it alone. Is that okay? Yeah. Cool. It is alright actually. I think we're actually alright with this. Now particle starts at point P whose displacement from the origin is 12i plus 5j and moves so that the velocity in meters per second is given by the following. Find the velocity vector at t equals 4. Well, that's simple, isn't it? Sub in 4. 2 times 4 is 8. 8 plus 1, 9i. 12 take away 24. Minus 12j. You all okay with that? Okay. Find the speed of the particle at t equals 4. Well, the speed is currently 9 across and 12 down. So I'll just do Pythagoras' theorem here. 225. Square root that to get 15, I think. I'm just flexing now. Well, wrote it in my head, but yeah. Anyways, find the magnitude of the constant accelerations, the magnitude. All right. So we have to differentiate one more time. So 2t turns to 2i minus 6t. 12 turns to 0 minus 6t differentiates to minus. Now, it wants the magnitude, so that's going to be 2 across and 6 down. Pythagoras' theorem that you get root 40 because it's 2, it's like basically the square root of 2 squared plus minus 6 squared. 2 root 10? Yeah. 2 root 10 meters per second squared. Okay. Particle is moving in a curve in such a way that the displacement at time t in seconds from a fixed point O is given by this formula here. Find the velocity vector at any time. Well, I'm just going to differentiate this and make sure that I turn them into the correct trigonometric function, okay? So, we're going to leave the 2 alone, but what does sine turn into? Yeah, so it turns into cos 5t, yeah? But then there's a hidden part. Differentiate the angle to get 5. And then we'll do the other one while we're here. 3. Oh. 3 minus sine 5t multiplied by 5 because differentiate the angle as well. So I'll be happy that the velocity vector is 10 cos 5t minus 15 sine 5t. Now, I forgot my I and j there, didn't I? My I is here and my j is there. All good so far? Find the acceleration. No hassle, I'll differentiate again. Alright, leave the 10 alone. What does cos 5t turn into? Then differentiate the angle. And there is a I there, isn't there? And what about the next section? Cos 5t. And then another 5 for differentiating the angle. And then your A value is, what you say? Minus 50 sine 5t I, yeah. Minus 75 cos 5tj. 55. Is that okay? Now here comes the fun part. So it's going to be relatively easy. Oh, sorry, I actually rubbed out the velocity, didn't I? Now, find the magnitude of the velocity at t equals pi over 2. Well, here's what I'm going to do. It's going to be 10 cos 5 pi over 2, I, minus 15 sine 5 pi over 2, j. Put your calculator into radians and do 2 separate calculations. Do the calculation for the yellow bit, do the calculation for the green bit. But don't do any like rounding or anything like that. Just if you can keep it as a decimal or a surd, please do. So once you get an answer, let me know.
First one is
0.
0.
Okay. Second one. Zero I. Minus 15j. Okay. Now, this is actually shockingly easy because you would get Pythagoras' theorem here, but is there any point? Because it's just going 15 downwards, so the overall velocity is just 15 meters per second. And then we're going to do the same for acceleration. We're going to replace the t with pi over 2 and do the exact same calculation. The first one's minus 50, is it? I minus 75j, is it? Yeah, oh yeah, it could be 0. Yeah. And then the magnitude is just 50. You would do Pythagoras' theorem now, like you would be doing 50 and 0. If they weren't both, if one wasn't 0, you'd do Pythagoras' theorem.